We're going to talk about the major points of a sine curve. Okay, and we have a sketch here. What I'm actually going to do is I'm going to sketch it on a graphing calculator first and then kind of bring it to how we might have to sketch it. So I've got our wonderful decimals program here. And a sine curve is essentially f at x, whoopsie, f at x is equal to sine, and that's the equation of it, okay? So there are some major key points, and this is called like a parent function. We haven't done any transformations to it, okay? It does pass through the origin. So we do have 0, 0, okay? And we're in degrees here, okay? Another key point is at 90 degrees, okay? At 90 degrees, excuse me, we're at the value of 1, okay? At 180 degrees, we're at the value of 0. At 270 degrees, we're at the value of -1, and at 360, like a full circle, we're at 0 again. Those points actually kind of refer to a circle, so we're going to draw a circle on the other side to draw a reference to it, okay? But these are 5 major points that you need to know. So those 5 major points, you can almost think of it like this, and see if I can build a nice circle here for us, okay? Imagine this circle. The middle of it is roughly there, okay? Imagine we're on a Ferris wheel and we're starting here on the circle, okay? When we go up to the highest point, okay, we've now created a 90-degree angle, okay? And we're going to say the radius of this circle, okay, is 1, okay? So I've now created a 90-degree angle. So we are at 0 and 0 to start, okay? That's where the equation of the axis is. Imagine like this is the ground and it's a circle going through the ground. So we're now 1 meter into the air, created a 90-degree angle, so we have the coordinate of 90 and 1. Okay. Then we continue and we get to the other side of the circle. We're flat again, but we've created a 180-degree angle. So now we're at the coordinate of 180 and 0. We're on the floor again. We've created that coordinate. The next coordinate comes around, or next major coordinate, okay? And this one has created a 270-degree angle, okay? And that's at the coordinate of 270, and we're actually a meter below the ground now. So we're at -1. And then finally, we come full circle. What haven't I used yet? Black, okay. We come full circle, okay? And we make a full 380-degree turn. And at 380 degrees, we're back at our middle point, but time has passed. We've gone 360 degrees. And that's the concept of here. We start, we get to our highest point, back to the middle, lowest point, back to where we started. Okay, that's the idea there. Some of the key points we want to talk about in an original one is, first of all, the equation of the axis. If you look here at our circle, the equation of the axis, think of it as it's at 0, where the ground is. So 0 would be right along the x-axis, okay? Here's our x-axis. This is where our y value is equal to 0. So we have an equation of the axis. I'll try to draw a colorful dotted line here so you can see it. The equation of our axis runs right through here. So the equation of axis is equal to, or maybe I'll do colon, y equals 0. That's how you would set up that linear function to represent that. Okay, the amplitude is the value of 1. So we know we have a coordinate at 0, 0. Okay. The amplitude, just like the circle we drew here, has a radius or a value of 1. So the highest point is at 1. So every 2 boxes, I'm going to go 90 degrees. Okay. So another 2, 180. Another 2, 270. Another 2, 360. Okay. So 2 boxes will be 1. 2 boxes will be -1. Our next highest point is at 90. We continue our circle. We got to the other side of the circle. We've done 380 degrees. We come down to -1, 270, and 360 again. So we've roughly drafted our sketch, and our graphing calculator probably does a way better job than I do of this. But the idea is now this farthest point to the highest value is a distance of 1. We're at 90 and 1, so that amplitude is 1. Same idea here. It's the same distance to the lowest point. The lowest point being 270 and -1. The distance is 1. So our amplitude is equal to a value of 1. The period of the function is how long it takes to rotate. Okay. Spell that right? Yeah, okay. The period of a function, well, how long does it take to go around a circle? Well, it takes 360 degrees. Okay. Domain and range. I could continue this, but the graphing calculator again would be way better. You'll notice that this goes on forever to the right and forever to the left. So for our domain of the function, okay, depending what notation you write, maybe you guys write x is the element of every real number, such that there are no limitations. So it just goes on forever and ever and ever. The range of this function, there are some limitations. So it is continuous, so we'll say y is the element of all real numbers such that, well, it has a peak. The peak of this function, the highest point is right here at 1. And the lowest point is right here at -1. And we show that on the graphing calculator. I can draw a straight line. Y at 1 touches all the tops. Y at -1 touches the bottom of all of them. Okay. So, in other words, it's contained within that range. So we know that y is less than, y is greater than and equal to -1. But y itself is less than and equal to the value of 1. We go from the lowest to the highest. Okay, so that would be our domain and our range of that function.